Hello everyone, it's Mrs. Davitt here, and today we're going to be discussing using trigonometric ratios to find missing sides. Now in class we started just by looking at triangles where we knew the different side lengths and making ratios of various combinations of the sides in the triangle. And we kind of honed in on three ratios that we'll continue to use throughout the course. They were sine, cosine, and tangent, and they looked like this. Okay, so when we're finding the sine of some angle, some acute angle in a right triangle, we would divide the opposite side length by the hypotenuse length. When we're finding cosine, we would divide the adjacent side length by the hypotenuse. And for tangent, we would divide the opposite side by the adjacent side. Now in class, what we did is we created this table of values based on all of the ratios that we could form. And we noticed that if we know the angle, the ratio of those two side lengths will always stay the same because of similar triangle properties. Okay, so this is really helpful because perhaps we have a missing side length and we're trying to find that side. We can use these trigonometric ratios to help us do that. Now we did talk about a little acronym that we can also use to kind of help us remember these formulas. It was SOHCAHTOA. Okay, so that SO comes from the SOH, that's that sine, is the opposite divided by the hypotenuse. The CA comes from CAH, cosine is adjacent divided by hypotenuse. And tangent comes from, this TOA comes from tangent, TOA, the opposite divided by the adjacent. So that can kind of just be like our little shorthand way to remind ourselves of which rule to use depending on what we know and what we want. So let's take a look at some examples. Now, before we actually get into any of the calculations that we're going to do, we need to make sure that our calculator is in degree mode. Okay, this is so important. Basically, your calculator can deal with angles in two different ways, and if it does not know we're in degree mode, we are never going to get the right calculations. So that's super important. Then I did, before we get into our examples, want to just give you a quick glimpse at some steps that we'll follow in all of the examples that we do. Okay, so what we are going to do first is label the sides of the right triangle. Which side is opposite the angle that we know or that we're using? Which side is adjacent to that angle? And it matters which angle we're looking from, right? And which side is the hypotenuse. Okay, then we will identify the trigonometric ratio that will help us in our scenario, write an equation using that ratio, and then solve for whatever we're trying to find. So here we go. Here are our examples. So when I look at example 1, the first thing I want to do is label my sides. Which side is opposite, in this case, the 43-degree angle that I was given? Which side is adjacent, and which side is the hypotenuse? So I'm just going to go ahead and put an O, an A, and an H to stand for those sides. And you can see that I've also added the acronym SOHCAHTOA at the bottom of our screen just so that we have that to reference as we move forward. Now when I look at this triangle, I notice that I am looking to find the opposite side, because that's labeled X, and I know the hypotenuse because that's labeled 15. So when I think about that, opposite and hypotenuse, O and H, I must be using the SO part here, right? Sine. So I'll go ahead and write down our sine formula, and then I'm going to fill in the values I know. Now keep in mind that theta is the angle, right? So we're going to go ahead and fill that in as 43 degrees. And then we do not know the opposite side, that's X, but we do know the hypotenuse, that's 15. So when we plug in the values we know, our equation should look like this. Now in class we talked about how if we want to solve for X, it might be helpful to envision that sine of 43 being divided by 1. Doesn't change the value that we have, but it does kind of help set us up to solve for X. We also talked about how you could technically type the sine of 43 into the calculator and get a number, right? It is the ratio of sides for any triangle with a 43-degree angle if you take the opposite side divided by the hypotenuse. But it's often a very messy decimal, so we like to try to wait until the end of the problem to type it into the calculator if we can. Now the good news here is when we cross multiply here and we do 1 times X, we just get X. And when we cross multiply here, we just get 15 times that sine of 43. So before we know it, we've found x. And then this whole bit here, 15 times the sine of 43, I can just type into my calculator. And as long as I'm in degree mode, we should all get this answer, about 10.23 as our missing side. Awesome. So that's our first example. Same exact process for example 2. We're going to start by labeling our sides opposite, adjacent, and hypotenuse so we can kind of figure out what we have and what we want. Okay, and in this particular triangle, it looks like I know the adjacent side and I'm looking for the hypotenuse, A and H. So which part here is going to help me? Because it's the A and the H. Cosine. Okay, so let's go ahead and write down our cosine formula. And we're going to fill in the values we know. We know the angle is 20, we know the adjacent side is 6, and we know the hypotenuse is y. Again, if you'd like, you can kind of imagine that as being divided by 1 so that you can envision the cross multiplication step. Now when you do this cross multiplication, it's going to be a little bit harder because when you multiply here, you're not just going to get y. You're going to get y times the cosine of 20. So you end up with this equation, which is a little messier than what we had before. Before, in this example, when we cross multiplied, boom, we were done. We had x. Okay, so now we don't quite have y yet. We have to think about how to solve for y. So just envision that y was being multiplied by any number. Let's say it was like y times 2. To solve for y, to undo multiplication, you would divide. So we don't have y times 2. We have y times the cosine of 20, but still, to solve, we can divide. Now again, we could type cosine of 20 into the calculator and get a decimal value, but it would be messy and we'd have to round. So if we can, we like to try to just wait until the end of the problem. So I am going to divide, as weird as it looks, both sides of my equation by the cosine of 20. Why would I do that? Well, cosine of 20 divided by cosine of 20 right here will just equal 1, which means it kind of just leaves us with y. Okay, and y will be equal to that quantity we had here, 6 divided by the cosine of 20. Then, when I go ahead and simplify that, in my calculator, as long as I'm in degree mode, I should get y equals 6.39. So that was just 2 examples of how to use SOHCAHTOA to calculate our missing side lengths. Now you might notice that we did not do a tangent example, but I hope you can envision that a tangent example would be no different than sine or cosine. It would just be that first step of which sides we're trying to relate, and the last step of what button you press in the calculator when you're trying to remind the calculator to dig up the right trigonometric ratio. So thank you for joining me. I hope this gives you a better understanding of how to tackle sine, cosine, and tangent or trigonometric ratio problems. Thank you.